Now, Bernoulli's equation is basically linear differential equation, but the difference is that the form that it comes as something more or something extra to linear differential equation. So basically, Bernoulli's equation is basically equations reducible to linear equation, right? So let's look at it now. It comes when you have the form dy dx plus py is equal to qy raised to the power of n, then it is a Bernoulli's equation. This one is Bernoulli's, right? It is Bernoulli's equation, right? Because of this y raised to the power of n. We know that for linear differential equation, it did not have y to the power of n. But for this one now, we have y to the power of n. So that means it is Bernoulli's equation. So now, just the same way, the integrating factor for this one is going to be e to the integral of 1 minus n. Then we have p dx, right? We have 1 minus n, then we have p dx. So the difference, you can see the difference now. For linear, we just add the exponents of the integral of p dx, right? There was no 1 minus n there. Now we have this, and then the formula is going to be y to the power of 1 minus n times the integrating factor is equal to the integral of 1 minus n times q times the integrating factor dx plus c. So now we can see the difference in the two equations. The basic difference is this 1 minus n and the y raised to the power of n. So for Bernoulli's equation, the things that we need to find are p, we need to find q, and then we need to find n, right? And we also need to know 1 minus n, but if you get n, we know 1 minus n already, right? So now let's look at the question. We're going to be looking at two questions under this video. So now the first question that we're going to have is x squared dy plus yx plus y dx is equal to 0, right? So we have it in this form, and basically we cannot separate this, right? So equations of variable by separation of variables will not work. You can pause the video to try and separate it, so you see why it's not going to work, right? But basically it's not going to work if we try to separate it. And right, so now since it cannot work, the next thing is going to be to check, right? You check whether you can use linear equation or Bernoulli's equation, right? If you can put it in the form of linear or Bernoulli's equation. If you can put it in that form, then you're going to use linear or Bernoulli's equation. But if you try and it still does not work, the next thing is going to be to try homogeneous equation, right? So if you try homogeneous equation, you try equations reducible to homogeneous equation, and those ones do not work, then you have to try exact differential equation. So that I'm just basically giving you the breakdown of how you can identify which method to adequately use for these questions, right? But with time, as you practice more questions, you get to become accustomed to different questions. So you just know by looking at this question, oh, this is what I should use, or this is what I feel I should use, and you just check one or two conditions, and if they are true, you continue solving. All right, so for this one now, what we're going to do is that we're going to first take this one to this side, and the reason why we are doing that is so that we can get dy dx, right? I want to divide everything by dx, right? So we're going to have x squared dy is equal to, I'm going to multiply everything in the bracket, right? So I'm going to have xy plus y squared, then I have dx. I'm going to divide both sides by dx. So doing that, I'm going to have x squared dy dx is equal to xy plus y squared. So what I can do here now is divide both sides by x squared, so that I do not have anything with my dy, because in this formula I have nothing with my dy. So I'm going to have dy dx is equal to xy over x squared plus y squared over x squared. Now I'm going to have dy dx is equal to y over x plus y squared over x squared. So what I can do is I'm going to take this one to this side, because on this side I have p on this side and not on this side, right? And it's very important that we do that so that we do not mess up the signs, because the sign is very important when solving. So we have dy dx minus 1 over xy, right? It's the same thing as y over x is equal to y. Let me put 1 over x squared y squared. So now you can see that it is exactly the same form as the base form, right? Dy dx plus py is equal to q y raised to the power of n. Because we can see here that way we have y to the power of n, which is 2, and here we can see py here. So that means p is equal to negative 1 over x, then q is equal to 1 over x squared, right? Because p does not have y squared. Y raised by n is another thing. So we have n equals to 2, then 1 minus n 1 minus n is equal to negative 1, right? So now we're going to apply our formula for integrating factor. It is the exponent of the integral of 1 minus n multiplied by p dx, which is going to be equal to the exponent of the integral of negative 1 multiplied by p dx, which is going to be negative 1 over x dx. Negative 1 times negative 1 will give us negative 1. So we have e to the integral of 1 over x dx, and this is going to be equal to e to the integral of ln x, and the exponent will cancel the ln, so that's equal to x. So our integrating factor is x for that question. And then we're going to apply our formula y to the power of 1 minus n. 1 minus n is minus 1. So we're going to have y raised to the power minus 1 multiplied by integrating factor, which is x, times the integral, okay, is equal to the integral of negative 1 times q, which is 1 over x squared, multiplied by integrating factor, which is x. Then we have dx plus c. 1x here, we cancel 1 of the x here. Let me rub off this side so that we can have ample space to solve. Right, so now we're going to have y to the power of minus 1, and that is basically equal to 1 over y, then times x. So we're going to have x over y is equal to the integral of negative x dx plus c. Then we can bring negative x out, so we have xy equals to negative 1 x dx plus c, and then we're going to integrate x. So we're going to have x over y, so this will be 1 over x. Yeah, 1 over x. So we have equal to negative ln x, then we have plus c. And this is, we're going to look at one more question. We'll look at one more question, and then we'll end the video. Alright, so let's look at this question. We have dy dx is equal to y tan x minus y square sec x. So we have this, and we are going to now solve this question. Alright, so I just remember something from the initial question. When we took the values that had dx to the other side, we did not include a negative sign, right? And that affected our answer overall, right? So please, just when you're doing your own, you can check that condition and just check. So basically the entire idea, everything we did was correct, right? It's just that the negative sign that we missed, right, affected the answer in the end, right? So now let's solve this question. So now we're going to bring it to the form, to this form, right? So we're going to have dy dx. We're going to bring this one to this side. So we have minus y tan x is equal to negative y square sec x. So right, so we have this. Now we're going to have our p. Our p is going to be negative tan x. Our q is going to be negative sec x, and then our n is going to be 2, and then 1 minus n is going to be minus 1. So we have our integrating factor. So we're going to have e to the power of negative 1 multiplied by negative tan x dx. So negative will cancel out negative. So we're going to have e to the integral of tan x, right, dx. Now the integral of tan x is going to be negative ln cos x. Remember, you should have this at the back of your mind, all these trig functions. So we're going to have e negative ln cos x, which is going to be equal, so this, now this minus 1 will come here, so we're going to have e to the power of ln cos x to the power of minus 1. This will cancel this, so we have 1 over cos x, which equals to sec x. And now we can go ahead and keep on solving our question. So now for this one, we're going to apply our formula. So we're going to have y to the power of 1 minus n, which is going to be minus 1, times our value for integrating factor, which is going to be sec x, then equal to negative 1 times q, which is going to be negative sec x, times sec x, which is our integrating factor. Then we have dx plus c. So here we're going to have sec x over y is equal to negative times negative will give us positive, so we have integral of sec square x dx plus c. And because we know the integral of sec square x is going to give us tan x, right? These are common knowledge. So we have sec x over y is equal to tan x plus c, and this basically is your final answer. Although you can still simplify if you want, you can cross multiply. So you have sec x is equals to y multiplied by tan x plus c, and this is your final answer. So it is that simple, and this is all on Bernoulli's equation. You can try out other questions in the 8th grade textbook. Thank you.